So what we have discussed in previous lecture? What we have discussed in previous lecture, anyone can repeat it? Online one.
Symbols.
Symbols. उसके बाद एक और लेक्चर हुआ है.
Silicon controller rectifier.
Yes. Construction and modes of operation of SCR is over. Is it right? Is it right?
Yes, sir.
Okay. So today we will discuss about the VI characteristics of SCR. Clear? So almost all same concept. So don't get any confusion. Modes of operation of SCR and VI characteristics of SCR. So both are same, but sometimes they can ask the question, explain the VI characteristics of SCR. Okay, sometimes they can ask the question, what are the modes of operation of SCR and explain. Yeah. So in both ways, they can ask the questions in both ways. So but answer is only one. So I will repeat it this topic. So see here, VI characteristics of SCR. VI means okay, voltage current characteristics. Okay, VI characteristics of SCR. So how we can draw the VI characteristics of SCR? So based on the modes of operation of SCR. Okay, based on the modes of operation of SCR, we can able to draw the VI characteristics of SCR. So draw this diagram here. So and this is the first experiment also. Please listen very carefully, all of you. And this is the first experiment also, practical. Clear? Next. All of you draw the circuit diagram. Online plus as well as offline. All of you draw the circuit diagram. Draw the circuit diagram, all of you. Clear? Screen is visible, na? Online.
Yes, sir.
What is this terminal? What is this terminal? What is this terminal? Anode. What is this terminal?
Cathode.
Cathode. Very good. Next, what is this terminal?
Gate.
Okay. This one is the gate. Very good. Okay, this is the switch. We are providing the one supply voltage. This is the main supply. This is the main supply. Clear? This supply is given to the. This supply is given to the anode voltage. Sorry, given to the thyristor across the anode and cathode. वही है ना? thyristor को दिए ना वो. This is the main supply. So this supply is given to the thyristor through the loads. Is it right? Thyristor को दिया ना? Supply दिया नहीं तो anode is connected to the positive. This is the positive. This is the negative. Anode is connected to what? Positive. And cathode is connected to what?
Negative.
Negative. That's very good. Okay. So this is the main supply, and this is the voltage for the gate circuit. So what we can write here, easy लिख सकते हैं क्या अपन E suffix G, gate voltage. Can we write like this? Please, all of you listen very carefully, online students. Okay, this is the easy. Easy means gate voltage. Okay. This is the variable. So by varying this one, which voltage is varying? Can anybody tell? By varying this one, which voltage is varying? Supply voltage is varying, no? Supply voltage means voltage across the anode and cathode, that will be varying. अगर आपने इधर 100 volts पे point रखा है, तो इधर भी 100 volts present रहेगा. If you put at the 200 volts, so इधर भी 200 volts present रहेगा. Is it right? So means by varying this one, the voltage will be varied. So the same voltage is applied to the thyristor across the anode and cathode terminal. Is it right? Next one, if this is varying, अगर ये rheostat vary किया तो क्या हो जाएगा? Which voltage is varying? Whatever we have given to the gate voltage, that will be varying. Is it clear? If you have given the 5, so 5 volt is applied to the gate. If you increase the gate voltage by using this rheostat, okay, or variable, so gate voltage is increased. Is it right? So here always we need to give the two supplies voltage sources. One is for the voltage across the anode and cathode, and the second one is the gate. Clear? This concept is clear. First point. And second one. So how we can draw the VI characteristics? VI means voltage and anode current. Voltage means here which one? Not supply voltage. Voltage across the anode and cathode. Clear? Okay, take graph like this, x-axis and y-axis. So take on x-axis, which one? Voltage across the anode and cathode. Is it okay? Take x-axis, voltage across the anode and cathode. So like this same way, take the anode current on y-axis. Take the anode current on y-axis. This is the IA. Okay. So what is the operation of the SCR? Generally, the SCR will be operates in 3 modes. SCR or thyristor will operate in 3 modes. What are those? What are those? कौन सा मोड में ऑपरेट होता है?
Active.
These are the three modes: reverse blocking mode, forward blocking mode, and forward conducting mode. Clear? So this forward conducting mode is also called as transition mode. ट्रांजिशन मींस एक मोड से दूसरे मोड में शिफ्ट होता है, ऑफ स्टेट से लेकर ऑन स्टेट में शिफ्ट होता है, उसको बोलते हैं ट्रांजिशन मोड. क्लियर? सो जनरली यू कैन रिमेंबर ये फॉरवर्ड कंडक्टिंग मोड. सो आरबीएम इज reverse blocking mode, FBM forward blocking mode, and FCM forward conducting mode. So you can easily remember RBM, FBM, FCM. Clear? So off state, and on state. Okay, but don't tell the off state, on state. Off state के लिए क्या है? क्या situation है? Okay. So next one. In first case, reverse blocking mode में क्या होता है? To operate the SCR in reverse blocking mode, so positive supply is connected to the cathode and negative supply is connected to the anode. Okay, I will draw it, no problem. So because it is very important. For example, this is the thyristor. So here one more thing I can draw here. इधर ड्रा करूँ क्या? Okay. So this is the thyristor. How many layers are there? P N. Okay, P N P N. So this is the cathode, and this is the, what is this? Anode. So to operate the SCR in reverse blocking mode, so anode should be connected to the negative and cathode should be connected to the positive. Yeah, you know, like, can we draw like this? So anode is connected to the negative and cathode is connected to the positive. So means reverse voltage is applied across the SCR. So reverse voltage is applied across the SCR. Then what about the gate circuit? There is no voltage is applied to the gate circuit in reverse blocking mode. Gate current is zero. Gate current zero means gate को कोई supply ही नहीं दिया. Clear? So in this case, what will happening? Junction J1, junction J2, junction J3, junction J1, J2, and J3. So what about the junction J1 is the forward bias, reverse bias? Okay, junction J1 is the reverse bias, and then junction J3 is also reverse bias. Clear? So due to the reverse bias junctions J1 and J3, so there is no chance to flow the current from anode to cathode. Clear? उसके best example क्या दिया मैंने? So water tank. Water tank में क्या है? I have given the best example. This is the water tank. Clear? So these are the water. And here one gate is provided. And either another gate is provided. Is it right? Okay. So this gate is nothing but J1. This gate is nothing but J2. This gate is nothing but J3. So ये water इधर flow होने के लिए क्या करना है? ये gate भी open होना चाहिए. This gate is also open. This gate is also open, na? Then only the water can come to here. If the gate is closed, there is no chance to flow the water. Okay. So to open this gate, there is a one condition. So junction J2 should be a forward bias. If the junction J1 is forward bias, then it will act as a open gate. Gate open होगा तो पानी flow होगा. Clear? So but here the reverse bias junction है. But here the junction J1 is the reverse bias. So it will act as a closed gate, na? गेट क्लोज्ड है, गेट क्लोज है तो वाटर आएगा तो इधर से no. So like the same way, due to the reverse bias junction, so no current is flowing from p material to n type material. Okay, अगर इधर करंट फ्लो होना है तो इधर फ्लो हो जाएगा क्या? नहीं. So that's why no current is flowing through the junction SCR. It will not flow from positive to negative or negative to positive. कोई भी डायरेक्शन में फ्लो होने के चांसेस नहीं है. So simply in this mode, the switch is act as a open. The SCR is act as a open switch. Okay. In open switch, voltage is present. आपने जो वोल्टेज अप्लाई किया वो तो रहेगा ना, क्योंकि because switch is open है. So for example, if the switch is there here, switch off किया है. So if you check the voltage across the switch, you can voltage is present, but load is not operating because switch is off. Voltage present है, current flow नहीं होता है. Clear? जब switch on करेंगे तब क्या हो जाएगा? Current flow होगा. Okay, voltage across the switch is becoming zero. So this is the condition. Clear? So here, which voltage is applied? Reverse voltage is applied. So reverse voltage present रहेगा ना. So current is zero, but small leakage current is flowing. Okay, in reverse direction. Small leakage current. Switch तो off है, but small leakage current flow होता है. Very small. Okay, that is milliamperes or microamperes. So that current can be called as a leakage current. Clear? So how we can represent it in this one? So this is the anode current on y-axis and voltage across the anode cathode on the x-axis. Current present है क्या? Current flow होता है क्या? नहीं. Small current flow है ना, that is called as leakage current. Okay, this current is called as a leakage current. X-axis के magnitude कौन सा है? Leakage current है ना, very small. Okay, and the reverse voltage, if this voltage is increased, voltage across the anode and cathode. Okay, ये अगर वोल्टेज इंक्रीज किया है तो ये भी ग्राफ इंक्रीज होगा ना. क्लियर? सो दिस इज द रिवर्स ब्लॉकिंग मोड. if we are increasing the reverse voltage across the thyristor, so more and more, then what will happening at one particular voltage level, the thyristor is conducting reverse direction. thyristor turn on हो जाएगा at one particular. अगर ज्यादा रिवर्स वोल्टेज अप्लाई किया तो क्या हो जाएगा? thyristor turn on हो जाएगा. ओके, थायरिस्टर टर्न ऑन होता है और रिवर्स करंट फ्लो होता है. जब रिवर्स करंट फ्लो होगा कैथोड पे एनोड करंट फ्लो होता है तो वो थायरिस्टर डैमेज होने के चांसेस है. दैट शुड नॉट बी हैपन. क्लियर? जितना मैक्सिमम वोल्ट रिवर्स वोल्ट वहां तक अप्लाई करें, उससे ज्यादा अप्लाई तो क्या हो जाएगा? थायरिस्टर डैमेज हो जाएगा, टर्न ऑन हो जाएगा, रिवर्स करंट फ्लो हो जाएगा, हीट बढ़ जाएगा, डैमेज होने के चांसेस है. इट इज क्लियर? सो एट व्हिच वोल्टेज लेवल्स द ब्रेकडाउन इज अकर्स, okay, that voltage can be called as reverse breakdown voltage, VRB. Can we write like this, VRB? ये वोल्टेज कौन सा? जिस वोल्टेज के पास ब्रेकडाउन अकर होगा उसको बोलते हैं, उस that voltage can be called as a reverse breakdown voltage. Okay, that is represented by VRB. Clear? So what is this one? ये गैप कौन सा मैग्नीट्यूड है ना करंट का? ये मैग्नीट्यूड है ना. सो ये कौन सा, क्या लिख सकते हैं अपन इसको? रिवर्स लीकेज करंट, आरएलसी लिख सकते हैं क्या? नॉट रेजिस्टिव इंडक्टेंस कैपेसिटेंस, आरएलसी में रिवर्स लीकेज करंट. जस्ट आई हैव रिटन लाइक दैट. ओके, सो दिस इज कॉल्ड एज रिवर्स लीकेज करंट. सो नेक्स्ट वन. So this point is clear. Next one, second mode, forward blocking. One more point, in reverse blocking mode, what about the junction J2 for forward bias? Reverse blocking mode में junction J1 J3 are the reverse bias, junction J2 is the forward bias. Clear? Next one, in second case, what is the second mode? Forward blocking mode. Online students, are you able to follow? Are you understanding, please?
Yes, sir.
Okay. So to operate the forward blocking mode, so anode should be connected to the positive, cathode should be connected to the negative. Just reverse. Yeah. So, but still the gate is open. But the still is gate is open means no voltage is applied to the gate. Okay. So in this condition, what will happen? What of the junction J1? Junction J1 is the forward bias. Yes. Then what about the junction J3? Online students only getting the answer from offline, not getting answer from the online. What about the junction J1, J3? Forward bias or reverse bias?
Forward bias.
Okay, junction J1 and J3 the forward bias, junction J2 is the reverse bias. Is it clear? So, junction J1 and J3 forward bias means this same example water tank. Okay, this gate is open. So, if this junction J2, J1 is the forward bias means this gate is open. It will act as an open gate. Okay, so gate open होगा तो क्या हो जाएगा? पानी आ जाएगा इधर. पानी आ जाएगा इधर तक. But the junction jet is the reverse bias. So this gate is closed. So यहाँ तक आके रुक गए पानी water. Clear? So to flow the water from this place to this place, so definitely the junction J2 and J3 should be open. So here in our subject, junction J1, J2, and J3 should be a forward bias. Then only the current can flow the anode to cathode. Okay. First here junction J2 the reverse bias. So due to this, there is no chance to flow the current from anode to cathode. Still it will act as a open switch. Is it right? Still it will act as a open switch. Clear? So open switch में क्या होता है? Current flow होता है कि नहीं? Zero. But small leakage current flow होता है. Okay, that is called as leakage current. But forward एक reverse है. Forward, because forward voltage is applied here. So that's why whatever the leakage current is flowing during the forward blocking mode, that current can be called as a forward leakage current. Okay. So this current is represented by like this. Forward leakage current like this, small magnitude. If we are increasing this voltage across the anode and cathode, so the voltage is also increased. The voltage is also increased like this. Okay. Is it clear? Up to this point is clear? Okay. This point is the, for example, A point. O, this is the, for example, P. अगर this is the O, this is the P, and this is the क्या लिख सकते हैं अपन? Q ले सकते हैं point. Q ले सकते हैं ना? O, P, Q, R, S, R, 1, 2, 3. Just points. You can represent the points. So what is this one? ये कौन सा है? लीकेज करंट है ना ये? What we can write here? FLC, forward leakage current. So can you give the definition for the forward leakage current? What is forward leakage current? So during the forward blocking mode, the SCR still operates as an open switch. So no current is flowing from anode to cathode, but small leakage current is flowing from anode to cathode. So that current can be called as a leakage current. So this current can also be called as a forward leakage current. So like this we have to give the answer. Clear? Next one. Second mode is clear, all of you? What is the third mode? What is the third mode?
Forward conduction.
Yes, forward conducting mode. So what is the condition to operate the forward conducting mode? Forward conducting mode means thyristor को turn on करना है. Thyristor को और SCR को turn on करना है. How we can turn on the SCR? By using the forward conducting mode. So forward conducting mode में condition क्या है? Yes. Exactly. Means same condition, anode should be connected to the positive supply, cathode should be connected to the negative supply. So like this. anode is connected to the positive and cathode is connected to the negative. Is it clear? So ये डायग्राम में मैंने ऐसे ड्रा किया है, दोनों सेम है. Are you got? Okay. Next, gate should be some amount of voltage is applied to the gate circuit. The gate switch should be closed. So यहाँ पर क्या किया अपन, गेट को भी वोल्टेज अप्लाई किया. Clear? This is the condition. So when the voltage is applied to the anode and cathode, so the junction J1 and J3 is the forward bias and junction J2 is the reverse bias, so it will operate as a forward blocking mode. When the gate circuit is closed, means when the small amount of voltage is applied to the gate circuit, then what will happening? The some currents are injected into the inner P layer. Okay, अगर ये current carriers, these current carriers are spreaded in whole area of the inner P layer. Okay, then what will happen? Whatever the reverse junction is formed, so the reverse bias, whatever the reverse bias junction is formed at junction J2, so that is called also called as valence band. ये gap है J2 के पास, जैसे जैसे गेट वोल्टेज इंक्रीज होगा, करंट इंजेक्ट होगा इनर पी लेयर को, वो करंट जो भी इंजेक्ट होता है इनर पी लेयर का सरफेस एयर भी स्प्रेड होता है. जैसे जैसे वो स्प्रेड इंक्रीज होगा, जो करंट कैरियर इंजेक्टेड करंट कैरियर्स आर इंक्रीजिंग more and more. So whatever the layer is formed at the junction J2, that is going to be decreased. Okay, so at one particular voltage level, this layer is totally finished and the junction J2 is act as a forward bias. Okay, so then what will happen? Whatever the valence band is present at the junction J2, that will be finished, that will be vanished, and when it is vanished, the current is flowing from anode to cathode because J1 already forward bias है, J3 already forward bias है. So junction J3 भी forward bias हो गया ना by giving the some amount of voltage to the gate circuit. So junction J2 is also become a forward bias. So when it will become a forward bias, so the current is flowing through the device. So it will act as a closed switch. Okay. So when the current is flowing from anode to cathode, positive, anode, cathode, and negative. So like this way the current is flowing. Clear? So here we can say when the gate current is applied, okay, when the gate current is applied, the current is flowing through the gate circuit. So the SR will be turned on. Listen, SR will be turned on. When the SR will be turned on, the current is flowing like this. Is it clear? The current is flowing through the like this. So whatever the current is flowing through the thyristor, that current can be called as an anode current. When the switch is turned on and the current is flowing through that switch, okay, that current can be called as an anode current. Is it right? So when SR is turned on, current increase होगा, voltage क्या होगा इसका क्रॉस? इसका क्रॉस voltage क्या हो जाएगा? इसके अक्रॉस वोल्टेज क्या होगा? स्विच टर्न ऑन है, स्विच टर्न ऑन है तो वोल्टेज अक्रॉस द स्विच जीरो ना, जीरो हो जाएगा ना. सो व्हेनेवर द स्विच इज टर्न ऑन, सडनली द वोल्टेज अक्रॉस द स्विच बिकम जीरो. ओके, सो द वोल्टेज बट स्मॉल अमाउंट ऑफ वोल्टेज विल बी ड्रॉप. पूरा जीरो नहीं होता है, थोड़ा सा ड्रॉप होता है, दैट इज 1 वोल्ट और 2 वोल्ट्स, दैट इज डिपेंड्स अपॉन द रेटिंग ऑफ दिस थायरिस्टर. ओके, सो सडनली the voltage is dropped. Clear? And the current is increased. वोल्टेज ड्रॉप होगा ना, एक्स एक्सिस में वोल्टेज है ना, पहले मैक्सिमम था उसके बाद सडनली डिक्रीज हुआ, डिक्रीज हुआ ना, करंट क्या होगा? इंक्रीज होगा. सो दिस इज द करंट इज इंक्रीजेस. ओके, ओ पी क्यू, दिस इज द आर पॉइंट and this is the S point. Clear? So the point from OP is called as कौन सा मोड है? RBM है कि क्या? RBM ना, रिवर्स ब्लॉकिंग मोड. पॉइंट OP ये रिवर्स ब्लॉकिंग मोड है ना. Are you getting? Next, from O to Q, this is the Q. वो क्यू क्या है? फॉरवर्ड ब्लॉकिंग मोड। नेक्स्ट R2S RS फॉरवर्ड conducting mode. So this is the VI characteristics of SCR. Easy again. So this is the we have shown like this. So here IG, what is IG1, what is IG2, what is IG3 means IG1, IG2, IG3 क्या होता है? अपन बोलो ना जैसे गेट करंट इंक्रीज होगा, जितना गेट करंट इंक्रीज करोगे उतना जल्दी टर्न ऑन होगा, जितना गेट करंट इंक्रीज करोगे उतना जल्दी टर्न ऑन हो जाएगा। Okay. So if gate current is at IG1, the thyristor is turned on at this point. If gate current is at IG1, the current is at this point. If gate current is increased from IG1 to IG2, okay, gate current is increased, और जल्दी turn on हो जाएगा thyristor. If the gate current is again increased from IG2 to IG3, again thyristor will turn on at less voltage levels. Clear? That is the meaning of this IG1, IG2, and IG3. So here IG1 greater than IG2 greater than IG3. Is it clear? So these are the magnitude of the gate currents. So simply remember, जितना gate current increase करोगे उतना जल्दी thyristor turn on होता है. Okay. So these are the VI characteristics of the SCR. So is there any doubt this one? Because I have repeated this topic second time. Last one, modes of operation of SCR, and this one, VI characteristics of SCR. Topic is same, but sometimes they are asking the question different ways. Explain the VI characteristics or explain the modes of operation of SCR. But same ही है ना, graph तो draw करना है, graph should be drawn as well as we have to explain the one by one mode. Clear? Any doubt, please?
Hello.
Yes, please.
For E and PN layer of SCR, the VI characteristic is same as that of this characteristic or different.
So please, can you repeat it the question?
For E and PN layer of SCR, the characteristic of VI is same as that of SCR or different.
So NPN और PNP SCR नहीं है इधर, only PN SCR है. ट्रांजिस्टर है, NPN ट्रांजिस्टर है, PNP ट्रांजिस्टर है. But here NPN and PNP SCR is not there. Okay, this is the 4-layer device, PN. Okay, your doubt is clear? Please. Your doubt is clear?
Yes.
Okay, but you are telling PNP and NPN, that is in the case of transistor. Okay, but here we are discussing the SCR. SCR is the PN device. Okay, SCR में PNP NPN device नहीं है. Clear? Okay, so even though PNP or NPN transistor also, जब switch turn on होता है, what about the voltage and what about the current? जब switch turn off होता है, what about the voltage and what about the current? Just PNP and NPN में flow of current direction changes होता है बस. Okay, NPN में क्या होता है? Collector to emitter. PNP में क्या होता है? Emitter to collector current होता है. That is the difference. But voltage and current characteristics are same. Next, any doubt? Next student. Next students, please. So because this is we are going to perform the experiment on this circuit, and we have to draw these characteristics. After performing the experiment, so we need to get these characteristics. So ये characteristic draw करना पड़ेगा तुमको. Readings लेने का और readings ऐसा आना चाहिए. Readings लेके graph draw करेंगे ना, तो it should be like this. Clear? So next Thursday we have a practical. So in that the laboratory, so in that practical session, we will conduct the VI characteristics of SCR. Okay, so we can complete the one experiment. Is it clear? So everybody should draw this circuit as well as this this characteristics, VI characteristics. So one more thing here you have to remember. So we are not drawing the voltage versus current. Supply voltage का anode current का versus draw नहीं करते थे. Supply voltage is different and voltage across the thyristor is different. Please remember. Okay, if the thyristor is turned on, voltage across the thyristor becomes zero, but supply voltage is not becoming zero. Supply voltage is not becoming zero. Please remember, all of you. So very small, little bit confusion is there here. Here we are drawing the voltage across the anode and cathode and current through the thyristor. So we are not drawing any characteristic about the supply voltage. Supply voltage same as it is रहेगा. Supply voltage same as it is रहेगा. Okay, इधर एक switch connect किया मैंने supply से लिया है. Switch turn on है turn off, लेकिन supply voltage तो same रहेगा ना. Supply voltage will not be increase and decrease. Even though switch is turn on and turn off, that is irrespective of the supply voltage. But switch का cross voltage changes होता है. जब switch is turn on, voltage across the switch is zero. When the switch is turned off, voltage is present. Is it clear? So don't get any confusion. This is the supply voltage as well as voltage across the thyristors. Clear, all of you? Is it clear? Kajal, Preeti, Bagal, Preeti.
Yes, sir.
Okay. So next topic we have to discuss. What is the next topic? Okay. So next topic is the turn on methods of SCR. So in previous just we have discussed is VI characteristics of SCR. VI characteristic कैसे turn on कैसे करते हैं अपन. So gate को some voltage apply किया अपन SCR को turn on किया. That is one method. Is there any other methods to turn on SCR? That is the meaning of this topic. Other than the gate triggering technique, okay, is there any other methods to turn on the SCR? Yes. Okay. So if anyone asks the question, is there any other methods are there for turning on the SCR rather than the gate turn on? Simply you have to say the answer yes. Okay. So rather than the other than the gate turn on method, we have four more methods to turn on the SCR. What are those? Forward voltage triggering and gate triggering already we have discussed. And third one the dV by dt triggering. And third one is the fourth one is the what is the fourth one? Temperature triggering or temperature thermal triggering, and fifth one is the light triggering methods. These are the five methods are there to turn on the SCRs. These are the five methods are there to turn on the SCR. Okay, one by one we will discuss. Okay, tomorrow because it is very lengthy topic. So how we can turn on the using forward voltage triggering? How we can turn on the SCR using gate triggering? Already gate triggering already we know the concept. Okay, how we can turn on the dV/dt triggering? How we can turn on the temperature or thermal triggering or light triggering? Clear? So can we discuss tomorrow? Online? Just wait, please. I will take attendance. Nice. Date कितना? 223. Online roll numbers के लिए 1 2 6 6